Describing the domain and the range. So let's remember that our inequality signs are greater than, less than, greater than or equal, less than or equal. So the domain, keep in mind, is the representative for our x values. So what x values can we use? The range, in other words, the y representative, defines what y values we can actually use. Examples. 5 is greater than 2. Well, negative 2 is less than 3. Is this a true statement? Yeah, negative 2 is definitely less than 3, right? One example is, think of your bank account. Which do you prefer to have? A negative $2 bank account or a $3 bank account? Definitely 3 would be bigger, right? It would be more preferable. So negative 2 is less than 3. Notice the arrow points, in this case, into the smaller side. 5 is greater than 1 or equal to. Is this true? Yeah, 5 is greater than or equal to 1. In this case, 5 is greater than 1. Once again, notice the arrow points, or the closing of our inequality points to the smaller value. 5 is less than 5. This would be a false statement unless we add an equal to it sign. So 5 is less than or equal to 5. Now it's a true statement. So do check and ensure that they're true statements. 5 is less than or equal to 5. Yep, it's not less than, but it's equal, which works for this case. Okay, so describing the domain and the range. Let's start with open dots. Open dot. On a graph, we use open dots to denote that the value will not be accepted as a solution. Okay, if it's an open dot, we don't accept solutions. Closed dots, on the other hand, imply that on a graph, we use closed dots to denote that the value is accepted as a solution. So open dots, we don't accept the solution at that particular value. Closed dots implies that we will accept the solution at that particular value. Okay. We have a couple of different ways. The first way that we are seeing here is inequality notation, which is using greater than, less than, greater than or equal to, less than or equal to formats. So they are greater than or less than, or greater than or less than or equal to in both case scenarios. As an example, x is less than 5. We can also explain it through interval notation. Interval notation is through the use of parentheses or brackets. In this case, notice that we have as a definition or description, interval notations uses parentheses for open dots, whereas inequalities we only use the less than or greater than inequality signs. So for x is less than 5, that means we can go to negative infinity and up to 5. Those are our limits. Notice infinity, we can never reach infinity. So since we can never reach infinity, we add a parentheses. 5 is a limit, but it's still not acceptable as a solution, so we put a 5. Well, this is kind of hard to visualize. So in that case, let's try doing a quick sketch or graph. And this will be on a number line. X is less than 5, down at the bottom left. And once again, number line, starting with the center at 0, and going outwards. And keep in mind, our number line is originally pre-x-axis. So this is the x-axis, but before we call it x-axis. Starts at 0 and works its way out in the negative and positive directions. Negative to the left, positive to the right. So since x has to be less than 5, that means 5 is not an acceptable solution. So we draw an open dot with an arrow going to the left in this case. We can do a quick check. Is 3 less than 5? Yes, that's true. Is 2 less than 5? Yes, that's true. So that means our arrows point in the right direction. If we check 6, 7, or 8, 6 is not less than 5, 7 is not less than 5. So if we would have made our arrow in the opposite direction, it would have been wrong, as we could check. Okay, so Notice that our arrow implies it goes to the left forever. So arrow to the left, going back to our interval notation format. On the left side, we have a negative infinity. That's the lower boundary. Lowest value, negative infinity. Higher boundary is the 5. It goes up to 5 is the maximum. But 5 is not acceptable, so it takes an open dot, meaning we have to have parentheses. Another example, just for reference. X is greater than 2. Well, if we say x is greater than 2, then that would imply if we would graph it, it would take an open dot. And in this case, it will be an arrow pointing to the right. We won't sketch this one though. So interval notation would imply that 2 is the lower boundary, so 2 is the lowest value for x. And it goes to the right forever, so it goes up to positive infinity. Notice there's no negative sign on this one, which is why it's on the right side. 2 is not an acceptable solution because it's greater than, so it would take an open dot or a parenthesis in the interval notation format. Infinity, once again, cannot be reached, so we put a parenthesis. Another example. -3 is less than x, which is less than 5. So that means we have a limit from -3 all the way up to 5. Interval notation format, a couple of parentheses and a comma in the middle. Lower boundary, -3, higher boundary, 5. Once again, since it's an open dot, because we have a less than on both case scenarios or both sides of the x, that means we put parentheses on both sides of the, in this case, -3, and on the opposite side of the 5. So in other words, on the right side of the 5. Okay, so closed dots, that's when it's equal to or less than. Our example here, x is less than or equal to 6. Notice it goes to negative infinity. Once again, since it's negative infinity, we can never reach infinity. So we put a parenthesis. Keep in mind, for instance, if you count to infinity, you'll get tired eventually and stop counting. So the left side, where the infinity, negative infinity sign is, we put a parenthesis. 6 is an acceptable solution because it has an equal sign. So it takes a bracket on there. Notice a bracket on the right side. Okay, another example. X is greater than or equal to 1. Well, in this case, we're going x is bigger than 1. Well, bigger than or equal to. So it goes more or larger than 1. Well, it goes up to infinity if you want to count to the positive infinity side. So therefore, on the right side, we have infinity. The lower boundary in this case is 1. 1 is the smallest value we would have. Since 1 is an acceptable solution because the inequality sign has an equal sign, or it would be an open dot, closed dot, not open, right? Closed dot. Then it would take a bracket on the left side. So notice the bracket on the left side. Right side takes a parenthesis because infinity cannot be reached. And once again, an example for in-between boundaries. So we have a lower boundary and an upper boundary in other words. So -12 is less than or equal to x, which is less than or equal to 17. We have in this case 2 brackets because both of them are acceptable solutions, the lower boundary and the higher boundary. If only one of them would be acceptable, then you'd have a parenthesis and a bracket, depending on which one is and which one's not acceptable. So, once again, notice our brackets in both of these cases.